Hello students, happy morning. Class 12 Physics, Unit 1 Electrostatics Revision Continuation video. In today's class, let me see the book back questions from the subtopic Gauss law and its applications. Okay. First question, very short answer question, that is define electric flux. Okay. We know electric flux is the number of electric field lines crossing a given area normal to the electric field line is called electric flux. Okay, electric flux. It is represented by the symbol phi e. Okay, electric flux means number of electric field lines crossing through a given area. Okay, this is the area, the plate having the area A, number of electric field lines crossing through a given area that is placed normal to the field lines. Okay, this is known as electric flux. This is represented as phi E is equal to closed law of E vector dot dA vector. Okay, the unit of electric flux is Newton meter square coulomb power minus 1. Here it is a dot product. Okay, dot product of electric field and area vector. So flux is a scalar quantity. Flux is a scalar quantity. Okay, because it is a dot product of two vector, that is a scalar. So flux is a scalar quantity. Okay, then let me go for the next question, that is long answer question. Obtain Gauss law from Coulomb's law. Okay, for this we need to find Gauss law from Coulomb's law. Okay, for this I am considering a positive point charge. Okay, from that point charge at a distance r, I am considering a imaginary sphere. Okay, on that sphere we are calculating the total electric flux. Okay, we know flux can be considered as phi E is equal to closed law of E vector dot dA vector, that is equal to, it is a dot product, so E vector modulus dA vector modulus cos theta. Okay, E dA cos theta. Okay, here theta is an angle between E vector and dA vector. We know here the electric field and area vector are in same direction, so the angle between E vector and dA vector will be 0. So cos 0 became 1. So we can write this one as phi E is equal to closed law of E dot dA. Okay, here electric field on this surface, that is a spherical Gaussian surface, will be same. Okay, because the sphere having the same radius. Okay, so the electric field on that surface will be same. So I am taking the electric field out of the integral. Okay, then integrating the dA vector, dA, okay, small area on the sphere, we get the entire surface of the sphere. Okay, the surface of the sphere will be 4 pi r square. Okay, electric field due to the point charge at the distance r is E is equal to 1 by 4 pi epsilon naught q by r square. Substituting this, we get 1 by 4 pi epsilon naught into q into 4 pi. Okay, 4 pi going to cancel, we get q by epsilon naught. Okay, here phi is equal to q by epsilon naught. This is known as Gauss law. Okay, this is known as Gauss law. Gauss law can be stated as if the charge q, if the charge q enclosed by any arbitrary closed surface, it may be in any shape. Okay, here I am considering a sphere shape. Then the total flux through this closed surface will be equal to q enclosed by epsilon naught. Okay, we can find the total flux of this surface is equal to q enclosed by epsilon naught. Okay, this is known as Gauss law. Okay, let me see what are the important things needed to answer this question. Okay, Gauss law from Coulomb's law. Long answer. Gauss law from Coulomb's law. For this we need to consider a positive point charge. Okay, from a distance r from the positive point charge I am considering a Gaussian surface, okay, that is in the shape of sphere. Okay, we know the electric field from the point charge, positive point charge, will be outwards. Okay, so here I am considering a small area, that is dA vector. Okay, this is the area vector. The electric field also in this direction alone. Okay, so we need to find the electric flux on this surface. Okay, imaginary surface. We know flux phi is equal to closed interval of E vector dot dA vector. Okay, here it is a dot product of two vector. Okay, so we can write closed interval of E dA cos theta. Here theta is an angle between E vector and dA vector. Okay, E vector and dA vector are in same axis, so the angle between E vector and dA vector will be 0. We know cos 0 is equal to 1. Okay, so phi is equal to closed interval of E dA. Here electric field on that surface, on the surface of the sphere, will be constant. Okay, so taking the electric field outside the integral. Okay, integrating the small area on the sphere, we get entire area of the sphere, that is 4 pi r square. Okay, 4 pi r square phi e. We know the electric field due to the point charge at a distance r. Okay, that is E is equal to 1 by 4 pi epsilon naught. The value of the charge is q. Okay, then q by the distance is r square. Okay, substitute in the above expression, then phi E is equal to 1 by 4 pi epsilon naught q by r square into 4 pi r square. 4 pi r square. R square, R square, 4 pi, 4 pi. Going to cancel, we get phi E is equal to Q enclosed by epsilon naught. This is known as Gauss law in electrostatics. Okay, for answer this question, we need to know these points alone. Okay, the next question, that is the application of Gauss law. This is one of the application of Gauss law. Using Gauss law, we can find the electric field due to a infinitely long charged wire. Okay, see, for this question we need to find the electric field for infinitely long charged wire. Okay, so I am considering a infinitely long charged wire having the uniform linear charge density lambda. Okay, so I am considering the charge density as lambda. Then I consider the point P, that is at a distance r from the charged wire. Okay, then here we know for the charged wire it will be a cylindrical symmetry. So I am considering a Gaussian surface in the shape of cylinder. Okay, having the radius r and the length l. Okay, this is that Gaussian surface. Okay, in order to find the total electric flux for this Gaussian surface, okay, I am using the equation of electric flux, that is phi is equal to closed interval of E vector dot dA vector. Okay, using this expression we can find the total electric flux for this closed surface. Here this closed surface is split up into three surfaces. One is curved surface. Okay, then remaining two things are top surface and bottom surface. Okay, here for the curved surface, the angle between the electric field and the area vector will be 0. Both are in same direction. So for this surface, the angle between the electric field and the area vector will be 0. But for the top surface and bottom surface, the angle between the electric field and the area vector will be 90 degree. Okay, so these two surfaces will be 0. This will accommodate. Okay, so for that phi E became integral of E vector dot dA vector cos 0 became 1, that is E dA, that is equal to Q enclosed by epsilon naught. Here we are applying the Gauss law. Okay, then we know Q enclosed, that is equal to lambda L. Okay, here E is taken out. Okay, then dA integrating over the curved surface. Okay, then we get the curved surface area of the cylinder, that is 2 pi RL. then E 2 pi RL is equal to lambda L by epsilon naught. Then we need the electric field alone. Then E is equal to lambda LL cancelled, lambda by 2 pi epsilon naught R. Okay, here in order to write in vector form, E vector is equal to 1 by 2 pi epsilon naught lambda by R into R cap. Okay, here R cap denotes the direction of the electric field. Okay, here this electric field decreases with the increase in distance. Okay, and also it depends on lambda. If lambda is greater than 0, then the electric field is outwards. If it is less than 0, it will be inwards. Okay, let me see what are the important things needed to solve this question. Okay, our topic is electric field due to a infinitely long charged wire. Okay, for this we need the infinite long charged wire having linear charge density lambda, charged wire linear charge density, that is lambda. Okay, from that charged wire at a distance r, I consider a Gaussian surface. That Gaussian surface is in the shape of cylinder, cylindrical Gaussian surface. Okay, here it consists of 3 surfaces. Okay, in order to find the total electric flux, we know the formula phi E is equal to closed interval of E vector dot dA vector. Okay, here it consists of 3 surfaces. One is curved surface, remaining 2 are top surface and bottom surface. In curved surface, the angle between the electric field vector and the area vector, that is 0 degree. Okay, but in top surface, this is a unit vector, that is a area vector, it is a electric field vector. In bottom surface, electric field vector, here it is n cap. Okay, area vector. It is split up into phi E is equal to closed interval became curved surface, that is E vector dot dA vector, then plus top surface, that is E vector dot dA vector, then bottom surface, E vector dot dA vector. See, it is a easy one. The angle between E vector and dA vector for the curved surface will be 0. Okay, for this theta will be 0. For these 2 cases, theta will be 90 degree. Okay, here it is a dot product, we can write it is E dA cos theta. Okay, here also E dA cos theta, cos 90 is 1, cos 90 is 0, this is also 0. These 2 things will be 0, this will be accommodated, then phi E is equal to integral of E dA, that is cos 0 degree, it became integral of E dA. Okay, here electric field on that curved Gaussian surface will be same, so taking E out of the integral, then dA. Okay, integrating dA, that is area, that is curved surface area of the cylinder, that is 2 pi RL, then E 2 pi RL. Here L is a length of the cylindrical surface. Okay, then phi E is equal to E 2 pi RL. Okay, we know phi E is a flux. Here we are applying Gauss law. We know phi E is equal to Q enclosed by epsilon naught. Okay, then E 2 pi RL is equal to Q enclosed by epsilon naught. We know Q enclosed is equal to lambda L. Okay, substituting this, we get E 2 pi RL is equal to lambda L by epsilon naught. L going to cancel, then we get LL going to cancel, then we get E 2 pi R is equal to lambda by epsilon naught. Okay, we need electric field around E is equal to lambda by 2 pi epsilon naught R. Okay, here the electric field decreases with the increase in distance. Okay, and also the electric field depends on linear charge density. If lambda is greater than 0, electric field is outwards. Okay, if lambda is less than 0, electric field will be inverse. If suppose in order to write in vector form, E vector is equal to lambda by 2 pi epsilon naught r into r cap. Okay. Our next question, obtain an expression for electric field due to an charged infinite plane sheet. Okay, by using Gauss law. It is also a application of Gauss law. Here in this question, let me find the electric field due to a charged infinite plane sheet. Okay, so far I am considering a infinite plane sheet having the charge density, that is sigma. Okay, plus. Okay, having the charge density sigma. Then I consider a point P at a distance r from the plane sheet. Then I consider a cylindrical Gaussian surface having the length 2r, r plus r 2r. Okay, then the area will be A. This surface is perpendicular, this Gaussian surface will be perpendicular to the plane sheet. Okay, in order to find the total electric flux, so I am using the formula phi is equal to closed interval of E vector dot dA vector. Okay, here this Gaussian surface having three surfaces. Okay, one is curved surface, remaining two are left surface and right surface. Okay, here this is a dA vector in that curved surface. Okay, here this dA vector in the right surface, dA vector in the left surface. Okay, then it can be written as integral of curved surface E vector dot dA vector plus E vector dot dA vector, that is P right side. Okay, that is P dash, that is the left side, that is equal to Q enclosed by epsilon naught, applying Gauss law. Okay, here for the curved surface, okay, for the curved surface, the angle between the electric field and dA vector is 90 degree, so cos 90 will be 0, then this part will be vanished. Okay, then the remaining part E vector dot dA vector, that is P and P dash. Okay, then we know for these cases the angle between E vector and dA vector will be 0. For this two we can write integral of E dA plus integral of P dash E dA, that is equal to Q enclosed by epsilon naught. Okay, then for this we can say it as these are two things are the same, so we can write 2E integral of dA P. Okay, these 2 points are same around. Okay, then we can write Q enclosed as sigma A by epsilon naught. Okay, then the total area of the surface either at P or P dash. Okay, these two are same only, so we can write integral of dA vector is A, because we are considering the area as A. So then we get 2EA is equal to sigma A by epsilon naught, then E is equal to sigma by 2 epsilon naught. Okay, then in order to write in a vector form, then E vector is equal to sigma by 2 epsilon naught n cap. If suppose n cap is a outward unit vector that is normal to the plane, then the electric field depends on surface charge density. Okay, but here it independent of the distance r. Okay, so we can consider a infinite plane for infinite plane sheet at a distance r, at any distance the electric field will be same. Okay, because here the electric field depends on surface charge density. If suppose sigma is greater than 0, then the electric field is outwards. If it is less than 0, it will be inwards. Okay, let me see what are the important points needed to answer the question. Okay, first of all, diagram, that is infinite plane sheet. Okay, having the surface charge density sigma. Okay, then next I draw a Gaussian surface, cylindrical Gaussian surface. At the point P is located at distance r from the infinite plane sheet. Okay, this is also distance from r. Okay, this is point P dash. In order to find the electric flux for this Gaussian surface, we are using the formula phi is equal to closed interval of E vector dot dA vector. Okay, this is split up into three surfaces. phi is equal to, first one is curved surface. Here I am considering the area vector, that is dA vector. Then at that point the electric field will be E vector. Okay, curved surface E vector dot dA vector. Then left and right surface. Okay, first of all right surface, that is P E vector dot dA vector. Then left surface, that is E vector dot dA vector, that is P dash. Okay, here for this two, the electric field, the angle between the electric field and area vector will be 0. Okay, here also it is E vector, it is dA vector. The electric field and area vector are in same axis, so here theta will be 0. Here also theta will be 0. For this case theta will be 90 degree, so this will be cancelled. Okay, because E dA cos theta, cos 90 will be 0. This will become E vector dot dA vector, that is P. Here I put 2 because the point P and P dash are at the same distance. Okay, we can consider this one as same. Then this one became 2 integral of P E dA cos, that is 0 degree, cos 0 became 1. Then phi E is equal to, we get 2 E dA. Okay, then E is a electric field, at that point it will be same, so we can write phi E is equal to 2E integral of dA. We already considered the area of the cylindrical Gaussian surface will be A. Okay, so phi E is equal to 2E A. Okay, then applying Gauss law, we know flux phi E is equal to Q, that is Q enclosed by epsilon naught. Okay, then substituting this we get 2EA is equal to Q enclosed by epsilon naught. Okay, then we can write 2EA is equal to Q enclosed by epsilon naught. We know Q enclosed is equal to sigma A. Okay, that is sigma is a surface charge density. Then we can write 2EA is equal to sigma A by epsilon naught. A going to cancel, then electric field E is equal to sigma by 2 epsilon naught. Okay, in order write in the vector form, then E vector is equal to sigma by 2 epsilon naught n cap. Okay, here n cap denotes the direction of the electric field. Okay, here this equation represent the electric field does not depends on distance r. Okay, if r increases then electric field will be same, or r decreases electric field will be same. Okay, if suppose I am considering this point as r, if suppose r is taken far away from the sheet, then at that point also electric field will be same for infinite charged plane sheet. Okay, here this electric field depends only on surface charge density sigma. Okay, suppose sigma is greater than 0, then electric field is outwards. Sigma is less than 0, then electric field inwards. Okay, these are the important points you have to remember to answer this question. Okay, you have to write in this format alone. Okay, thank you.